Okay, page 8 of unit circle. Find all angles between 0 and 360 degrees with a sine of 1/2. So remember, sine is the y-coordinate. So the y-coordinate of 1/2, that would be like the wide triangle, right? It could be this triangle or it could be this triangle, either one. So this angle would be 30 degrees. And this angle would be 180 minus 30 degrees, which would be 150 degrees. So those would be the two angles with a positive 1/2 of a sine. Okay, what about a cosine of -1 over square root of 2? So -1 over square root of 2, that's going to be a 45, 45, 90 triangle. We just need to figure out which 45, 45, 90 triangle. So it couldn't be in the first quadrant because it's a cosine that's negative. Remember, cosine is an x-coordinate, so where are the 45, 45, 90 triangles that have a negative x-coordinate? It would be either this one or this one, right? These two. So this one would be 90 plus 45 degrees, or 180 minus 45 degrees, which would be 135 degrees, right? And then this one would be 180 plus 45 degrees, which would be 225 degrees. So those would be the two angles that have a cosine of -1 over square root of 2. They have x-coordinates that are -1 over square root of 2. Okay. Find all the angles between 0 and 4 pi. That's a little suspicious, right? It should be 0 and 2 pi. That would be like the normal upper limit. They're talking about 4 pi, so that would be 2 times around the unit circle, right? 1, 2. All right. A cosine of square root of 3 over 2. So here we're talking about an x-coordinate that is square root of 3 over 2. Square root of 3 over 2 is the long side of the 30, 60, 90 triangle. So that would be this triangle here. That would be a positive square root of 3 over 2. It could be this triangle here also. Also a positive square root of 3 over 2 in the x direction, right? So let's see. One of the answers would be 30 degrees, of course. Another answer would be almost 360, but short 30 degrees. So it would be 360 minus 30 degrees, which would be 330 degrees. And then, of course, if we're going to 4 pi, then we're going to go 2 times around. So that would be 30 degrees plus 360 degrees. And that would be 330 degrees plus 360 degrees. Okay, now remember, we do need to figure all these in radians. So 30 degrees is pi over 6. Okay, how do I know it's pi over 6? Because I'm going to divide this half circle into 6 pieces, right? So 30 degrees is pi over 6. 330 degrees would be 2 pi minus pi over 6, which would be 12/6 pi minus pi over 6, which is equal to 11/6 pi. And 30 degrees plus 360 degrees is 2 pi plus pi over 6, so that would be 12/6 plus 1/6 pi, which would be 13/6 pi. And then 330 degrees plus 360 degrees is 4 pi minus pi over 6. 4 pi, that would be 24/6 pi minus pi over 6, so that would be 23/6 pi. Okay, I know the hardest part of this is the fractions, but if you slow this video down, I'm sure you can figure it out. Okay, a sine of -1. So a sine of -1, that would mean the y-coordinate is -1, so that has to be this point here, right? What is the first angle that has a sine of -1? It would be 270 degrees. In radians, that would be 3/2 pi radians, 1.5 radians, right? And then what about if we went around twice? That would be 2 pi plus 3/2 pi, which would be 4 over 2 plus 3 over 2 equals 7 over 2 pi. Okay? All right. And next, number 9. Find theta if theta is between 0 and 2 pi. and cosine of theta equals 1/2. So basically we're saying the x-coordinate of the triangle is 1/2. That would mean the tall 30, 60, 90 triangle, right? It would be these two, right? The x-coordinate is the short side, positive. So one of the answers would be pi over 3, because 60 degrees is pi over 3. And then the other answer would be 2 pi minus pi over 3, because it would be this triangle here. So that would be 6/3 pi minus pi over 3 is equal to 5/3 pi. Okay? All right. And tangent of squared theta equals 3. So in this case, we do need to, do a little bit of algebra, do square root to both sides. And remember, if you introduce a square root, one of the sides should have plus or minus square root. So that would be tangent of theta equals plus or minus square root of 3, which means that, if we're talking about tangent of square root of 3, that would be a 30, 60, 90 triangle. It would be the tall 30, 60, 90 triangle. And which of these 4 triangles are we talking about? Well, if we're talking about plus or minus square root of 3, they would all be answers. Okay, so just to draw the triangle with all the lengths written in, remember that the standing up 30, 60, 90 triangle has an opposite of square root of 3 over 2 and an adjacent of 1/2. So that's why when you divide the two, you get square root of 3 for the tangent. Okay, so what are the answers here that we're going to give? One of them is going to be pi over 3, 60 degrees. The other one is going to be 120 degrees, which would be 2/3 pi. And then another one would be, what's that, like 180 plus 60. It's 240 degrees, which is going to be 4/3 pi. And then this one is going to be 5/3 pi. Okay. All right, those are the 4 answers for J. Number 10, find all the values of theta for which tangent of theta is 0. Oh, are we still talking about 0 to 2 pi? No, they want all. So that would be, from negative infinity to infinity. All right, so one of the possible answers, what angle has a tangent of 0? It would be a 0 degree triangle or a 180 degree triangle. So that would be 0 degrees or 180 degrees. Are there any others between 0 and 360? I guess 360 itself, right? Okay. But basically, you can see that this forms kind of a pattern, 0, 180, 360. Basically, every 180 degrees, the tangent of theta is 0. So we could say 0 degrees plus k 180 degrees, where k is an element of all integers. And then basically k could be any negative or positive whole number. You would plug it into there and that would be a solution. Okay, 0 degrees, 180 degrees, negative 180 degrees, etc. Okay, what about all values of theta which tangent theta is undefined? So undefined, that would be any triangle that is pointing straight up or pointing straight down, right? Because the tangent of 90 degrees is undefined and the tangent of 270 degrees is undefined. And so basically the pattern is 90 degrees, 270 degrees, could be negative 90 degrees, etc. That would be another way you could write it. You could write it as like ... negative 90 degrees, comma 90 degrees, comma 270 degrees, as long as you put 3 or 4 numbers to show the pattern. But I could also write 90 degrees plus or minus or plus. I could just put plus. Plus k 180 degrees, where k is an element of all integers. Okay, so that would be the answer for undefined. All right, next problem 8f, the equation of a straight line. If a straight line makes an angle theta with the positive x-axis, then its gradient or slope is, okay, so find the equation of each line. All right, so this is like a combination of, linear equations with trig. And remember, rise over run is when you draw a right triangle underneath the line, and the rise and the run relative to this reference angle, you can see, is the opposite over the adjacent. And if you're doing opposite over adjacent, what is that in trig? It's tangent, right? So basically what this is saying is the slope of this line is the tangent of 60 degrees, and the tangent of 60 degrees is square root of 3 because it's 60 degrees, right? Positive square root of 3. Okay. If you wanted to draw the relevant sides, you put square root of 3 over 2 for the rise and 1/2 for the run. Square root of 3 over 2 divided by 1/2 is square root of 3. Okay. Okay, so now we have this other line. We're supposed to find the equation of the line, so we need the y-intercept too. The y-intercept is 0. So our equation would be y equals mx plus c. M would be square root of 3, and c would be 0. So basically, it's just square root of 3x. And we're done. Okay. Next one. Our y-intercept is 3. What is our rise over run? Well, we know that this angle is pi over 6. Pi over 6, remember, is 30 degrees. So this angle would be 60 degrees. Oh, it's the same slope as the other one. So the slope is still square root of 3. And now our y-intercept is 2. Okay, so it's a little bit tricky because they gave us this angle, which is not the reference angle that they gave us before, which is down here. But we find this, the reference angle, by doing 90 degrees minus 30 degrees, and then we get 60 degrees again. Okay. What about this one here, C? So this one, they don't give us a reference angle. They only give us these two lengths. So this length they give us is 2 square root of 3. And this, oh, they do give us an angle. They give us this one. They say this is 60 degrees. Okay, so if this is 60 degrees, then this would be 30. So it's a 30, 60, 90 triangle. A 30, 60, 90 triangle has the proportions square root of 3 over 2, 1/2, and 1, right? So in this case, it's 2 times square root of 3. So that means this side here is multiplying this by 4, right? And then we would get 2 square root of 3. So we're going to multiply this times 4, and we're going to multiply this times 4. And then so these sides are going to be 2 square root of 3. 4 times square root of 3 over 2 would be 2 square root of 3. And this would be side 2, 4 over 2, right? And then the hypotenuse would be 4. We don't really need the hypotenuse, but I'll write it there anyway. Okay, so now we have this triangle, the rise of a run triangle. The rise is 2. The run is 2 square root of 3. And so the slope would be 2, which is the rise, over the run, which is 2 square root of 3, which is equal to 1 over the square root of 3. Okay, and the y-intercept is, let's see, the y-intercept would be -2, right? So I'm going to write my line equation here, 1 over square root of 3, x minus 2. And I'm done with the page and with the packet.